This video is about polymorphism as used in inheritance in Java. Polymorphism means that the same code can be used with different kind of objects, and that same code might do a different thing depending on what kind of object it's interacting with. An example of this would be if you had a method that took different kinds of objects as a parameter and did different things with different kinds of objects. So for example, systemoutprintln is able to print any kind of object by calling that object's toString method. And depending on the implementation of that toString method in that particular object, you might get a very different behavior, might get a very different appearance that would appear on the console when you print the object. Let's look at a sequence of classes that will help us to understand how polymorphism works in Java. We've created 4 classes that are sort of meaningless code. They have silly names like foo and bar, and they have methods where they're meaningless. They sort of say method 1 and method 2. The methods sort of print the class name followed by the method number. So for example, the foo class has a method 1 that prints foo1, and method 2 prints foo2, and so on. Then we have some other classes that extend from here. So the bar class, the second one here, extends the foo class, and it overrides the method 2 to print bar2. But of course, since it extends foo, it also inherits these other behaviors from the foo class, like method 1 and toString. On the next slide here, we have a couple other classes. We have a baz class that extends foo as well. It also has a method 1 and a toString. And we have a mumble class that extends the baz class that adds a method 2. So imagine that we're given these 4 classes, and now we want to figure out what's the output of the following client code, the following code that uses those classes. So we created an array of these things and put them into this array. First we have the baz, and then the bar, and then the mumble, and then the foo. And now for each of the elements of that array, we're going to print the object, and we're going to call method 1 and method 2 on the object. So basically what the question is asking is, what does method 1 and method 2 and toString do for each of these kinds of 4 objects? So that's what we have to figure out. So if you want to solve these kinds of problems, a couple strategies can be helpful. One strategy will be to just look at the different classes and see the relationships between them. So for example, if you look back at the original code, you saw that this foo class was kind of at the top of the inheritance tree. Everything else extended foo, or else extended some subclass of foo. So we could look at the 4 different classes, foo, and then bar extends foo, and baz also extends foo, and mumble extends baz, and that could lead us to draw a picture where we would say, well, here's the foo class, and here are the methods that it has and their behavior. And then here's the bar class that extends foo. It adds method 2 to the equation, but it doesn't change the other 2. It inherits them from foo. Then we have baz that extends foo as well, so it's a separate child of foo. And then we have mumble that extends baz. So drawing a picture like this can be helpful to understand the behavior. In case you're curious, this picture is an example of a standard software diagram called a UML class diagram. So a picture like this where you show the classes as boxes with kind of arrows from subclasses to superclasses, that can be helpful to understand the relationship between the classes. Now if you actually want to figure out the output from all the different methods, another technique can be useful, maybe after you've drawn this picture, is to make a table of each class and each method, and then just look back and forth between the code and this table to fill it in. So if we look at our code, let's look at the foo class, and let's look through all 3 of these methods for that. The foo class has method 1 that prints foo1, and it has method 2 that prints foo2, and it has toString that returns foo. So if we go back to our table here, then we would sort of write foo1, foo2, and foo for the behavior of these 3 methods. Let's just do that for all 4 classes real quickly. The bar class here has a method 2 that prints bar2. Bar2. And otherwise, it extends from foo. And so all the other methods are still there, but it inherits their behavior. So we can just go ahead and copy those over from the foo column of the table. So foo1 is the output of the method 1 here, and foo is the output of toString here. Okay, let's do the same thing for baz. Baz also, according to our picture here, extends from foo. So baz is the one that has a method 1 that prints baz1 and a toString that returns baz. So let's fill in that method 1 and that toString in our table. If we fill in the baz with method 1 printing baz1 and toString returning baz, then baz again extends from foo, And therefore, the methods that are not written in, like method 2, we're going to inherit the foo version of that behavior. So we're going to get foo2 here for the baz method 2 output. The last class in our table is the mumble class, and the mumble class actually extends from baz here. So that means anything that's not included in mumble, we will copy the version from the baz. If we look at the mumble code only has a method 2 that prints mumble2. So let's go to our table that we're working on here, and under method 2 we will write mumble2. And again, we said that mumble extends from baz. Therefore, any of the behavior that's missing here will copy the baz version, baz1, and for toString you'll get baz. So if we were going to try to figure out the output of the overall exercise, the client code, we would just look back, we would use this table and look back at the code that was written, and basically, look at the different columns of the table. We'd say, well, first we're going to do the baz output, then the bar output, then the mumble output, and then the foo output, and based on our table, that would give us the answer to this exercise. So now what I'd like to do is walk through a little bit more complicated example of the same idea. Let's look at another set of classes. So again, we have sort of meaningless classes with silly method names. In this case, we have the ham class and the lamb class and a couple of other ones. And the methods here are called A and B and toString. And the reason this problem is trickier is, first of all, I've jumbled up the order of the different classes. So in the first problem, the original superclass was the first one I listed, but in this problem they're jumbled up in order. Another thing that's trickier about this problem is that sometimes the methods call each other. So that's going to make polymorphism do some interesting things that we'll see in a minute. So we have lamb class, we have ham class, we have spam class, and we have yam class. And again, we're going to be given a piece of client code that uses these, and we're going to have to figure out what its output is going to be. Here's another thing that's tricky in this code. This yam class is calling a super class's version of the A method by using the super keyword. So that might also make our output a little more tricky to figure out. So here's a piece of client code that uses these things. We create an array where element 0 is a lamb, and element 1 is a ham, and element 2 is a spam, and element 3 is a yam, and then we loop over them and ask for the output of their toString and A and B methods here. So how do we figure this out? Well, again, we can make a table to look at the different classes and the different methods. Before we do the table, we probably want another one of those diagrams that shows the different classes. If you were to look through the code back on the previous slides here, you'll see that the one on top of the chain is ham, and then lamb extends from ham, and then we have spam extending yam and yam extending lamb. So if you look at all of those together, you'll find that the overall tree looks like this: ham at the top, followed by lamb, followed by yam, followed by spam. And in the diagram here, it's a little bit difficult to read, but the only methods that are in these are B is in lamb, and yam has A and toString, and spam has B. So we need to figure out the output here. If you fill in this table with the output from ham first, you got to work from the top down. That's the way you do these. So first we'll do the ham ones. The ham method A prints a sort of obvious output of ham A, and the ham B prints ham B, and the toString returns ham. So now we have to look at lamb. Let's go back to the lamb code and figure out what's going on here. Well, in the lamb class, we have only a B method. So A and toString are easy. Oh, excuse me, I've left something out. I'm sorry. In the A method of ham, we also call B. So that means that the code is going to jump over here to the B method and print ham B as well. I apologize. So in our table back here, we're going to have ham A and then ham B. That's going to be what gets printed by the A method. That single call is going to print 2 lines of output. Okay, so now let's go back to the lamb again. Sorry about that. In the lamb class, we only added one method to the code. The lamb class added a B method that prints lamb B. So let's go fill that in right away in our table. So in a table, we'll write in lamb B. So now the other methods are inherited from the superclass from ham. So you would probably think, let's just grab the output from the ham column and copy it over into the lamb column. So let's take the word ham and put this here, and let's take the ham A, ham B, and copy that into here. But actually in this case that's not quite right, and I'd like to explain why. It has to do with polymorphism. So if you look at the ham class, it has this A method. The A method prints ham A and then it calls B. Well, if you have a lamb class with a B method and it extends ham, then what you're doing is you're getting a copy of that A method. It's like you're inheriting that, so it's kind of like copying and pasting that down in here. But this call to the B method right here in this A code, it's going to call the B method in the lamb if I call the method on a lamb. So actually if I call A on a lamb object, it's going to print ham A followed by lamb B. So that's an important thing to understand. If a method is making a call to another method and your subclass replaces that other method, then that's going to affect the output that you see. So actually if we go back to our table here, instead of printing ham A, ham B, the output from this call is ham A, lamb B. And actually the way that you really want to write this in, if you're going to make a table, is if you see a call from one method to another, instead of writing the output in, you really should write in the call. You should say this calls B. And you'll know that that's going to call the ham's version of B. But now here when I'm filling in the table for lamb, if I copy that over to the right and I see that it's calling B, I'm going to know that it means to call the B from this object. So that's going to give me the right answer, ham A followed by lamb B. So that means my table won't confuse me, won't cause me to get the wrong answer. So let's look at the other two classes. We have the yam class. The yam class extends lamb and it overrides A and toString. So overrides A and toString. So let's go back to here. The B method is not overridden, so we'll just copy over lamb B. And the toString, it overrides to say yam. Those two aren't very difficult. The A method does get overridden, and what it does in the code here is that it prints yam A and then it calls super.a. So let's go back to our table for a second. It prints yam A and then it calls super.a. Well, what is super.a? Super.a is the version of the A method that comes from the superclass. So that's this output right here. So basically I can copy that over. I can say yam A, ham A, and then a call to the B method. And again, in this case, it's going to call the B method from this object, which is going to print lamb B. So actually, you get 3 lines of output if you have a yam object and you call A on it. You'll see yam A, ham A, lamb B. That's going to be the full output of that method. So now we've filled in the third column of our table. Let's do the last one, which is spam. And according to the original code, spam extends yam. So let's go and look at that. Spam extends yam, that's up here, and we're going to add a B method that prints spam B. That's it. So let's go back to the table. We're going to write spam B here, and we're not overriding the other two, so we can just copy them over. The yam is going to be the toString for a spam object, and the A output from a spam object, once again, we can copy this one over, but we have to make sure we understand what that means. We're going to copy over yam A, and we're going to copy over ham A, and the last thing is a call to B. And again, it's going to use the B method from the object that we are in. So now it's going to use the new version, the spam B, because we've overridden the B method here in the spam class. So if you call the A method on a spam object, you're going to get 3 lines of output, yam A, ham A, spam B. So this table gives us all the information we need to answer the original exercise.